All right, welcome everybody to week 17, day 2, last day of school. Go over the graph competency exam first, because the first thing was max flow, then shortest route, shortest path, things like that. So max flow from I to D. All right, where's my mouse? All right, plugged in? No. There we go. All right, so do you guys remember how to do max flow? It's like these numbers here indicate like gallons per second or cars per second or something, right? So we'll try to send 10 gallons per second this way, and 7 of them can go this way, and 3 of them can go this way. So that's 10. That doesn't. That's all gone. So we've got 7 coming in this way and 3 coming in this way, with 11 remaining. We try sending 15 out this way, of which 7 can go through this route, and then 8 would go through this route. And then there's enough capacity left for another 3. So you can have another 3 go this way. So it's just going to be 32, I think. Did I add that up wrong? I might have added that up wrong. Okay. 7 this way, 14 this way, 8 this way, 29 maybe? Seven one way, 14 this way, 7 this way. Yeah, so right. 7 this right. Yeah, so 7, a total of 7 can come this way, 14 this way, and 7 this way, right? So that's a total of 14, and 14 is 28. That's correct. Okay, so almost all of you guys got that one wrong, including myself. That's fine. I did it right when I made the quiz. All right. So, right. So we can have 7 units coming this way. We can have, we still have 3 left here. So 3 coming this way. 11 left. 7 coming up this way. And so that's 7, 3, 7, and then there's still enough capacity for 11 more. And we can find 11 more capacity coming in this way and this way. Okay. Use the cut method. Yeah, that works too. Min cut and max flow are the same thing. All right, so there we go. All right, so that was tough for you guys, looks like. Shortest distance between A and G. There we go. All right. So A to G, this one. Obviously, we got to go this way. It's 8 miles. Like M&M or something. I don't know. And then the shortest route from B to G is 25 this way, 22 this way, 20 this way. So it's going to be this way. 20 that way, 8 this way. It's a total of 28 also. Okay. So just happens to be 28 also has no relation between the two, right? I did think that was funny though when I made the quiz. Is there a Hamiltonian path and or a Eulerian path and or a Hamiltonian cycle and or a Eulerian cycle in the graph above? So a Eulerian can be ruled out because this one has a degree of this one has a degree of 3. Even this one has a degree of 5. This one has a degree of 3. So there's no Eulerian path, there's no Eulerian cycle. It's not possible. It's the bridges of Kingsburg problem. Königsberg. So no learning path, no Eulerian cycle. Hamiltonian cycle is going to be impossible because a cycle you have to end up where you started, and you can't do that with a person hanging out like that. But there is a Hamiltonian path. You can simply go like this, and that would visit every city on the map one time. Easy. Okay. So Hamiltonian means you visit every city once, and a path is visit every one once, and cycle is the same, except you end up where you started. Okay. So you can't end up where you started because there's no way of dealing with that. All right. You can't visit the same spot twice. Like, there's no cycle because, like, you'd have to go here and then, like, back. And then you'd visit the same node twice. Okay. All right, so looks like you guys did reasonably well on that one. What is the total distance in the minimal spanning tree of the graph above? Okay. So let's do a minimal spanning tree of this. So we're kind of hitting up all the graph theory things with this one graph. Okay. So we do prims or crystals. They'll more or less work out the same way. I'll just, yeah, all right. Smallest, fives. Smallest, 7. Smallest are the 8s. Smallest, and don't add this one again because it's already connected. Or you could add this one and not add that one, either way. It's all fully connected now. Total distance in the middle spanning tree, 15, 25, 40, 50, 55. Yep. So there you go. It helps if you like print it out and like working on paper. It's probably a little bit easier than doing it in your head, you know, because you might add the same node twice. You can't add this twice because that creates a cycle. Right, so for a minimal spanning tree, you basically add whatever the smallest edge is that is not going to create a cycle in the map. So, yeah, you can miss one and still pass it. So there will be another one. Look for that. So the latest competency exam I wrote last night at 4 o'clock in the morning, so hopefully there's no typos on that one. That one is up now. You can see it on the modules section. On recursion and proof by induction, so yay. Alright, and then there will be one more on probability and statistics. If you get a 3, does it count up to a 4? It does. It does. But for the Hamiltonian Eulerian, you have to get all the points on that. It rounds down. So if you got a 2.75, that's a 2. It's just been a while since you've seen the topics. Yeah, that's the point. We want to see if you retain the knowledge. Yeah. And that's actually one of the benefits of doing a final, is that we can test your long-term recall of things over, short-term recall. So maybe I'll do a final again next year. I don't know. It'll be interesting to see how I do stats actually. So what I do is whenever I have a homework assignment or something like that, I check to see if how predictive that score is of the overall score in the class. Obviously, there's going to be some correlation because it adds in, right? Like if you got an A on something worth half your grade, you're likely to get an A in the class, right? So I have to deal with that. But the competence exams I found when I did the analysis last year were actually the best predictor of overall performance in the class. So students that did the best on the competence exams were the most likely to get an A on the programming assignments and things like that, with the programming assignments being the second most important factor. And so I used to do code reviews, if you guys might remember that, but code reviews were the least predictive of success in the class. And the reason for that is because all you have to do is show up and do a code review and you get a 10 out of 10 on it. And so even the poorest students could just go to the tutorial center or whatever and get a code review. Because you don't actually have to write good code to pass the code review, you just have to do it. And so there were a number of good students who just forgot. And so I dropped the code reviews, even though that's actually one of my favorite things to do. And I feel like it gives you good experience with real life scenarios. So hopefully CSI 45 doesn't have a final. I might. So they're doing Lun's class right now. Shahab, how's that going for you? I haven't done the rounding on the Combinatorics C. Yeah, I will. Don't worry. You made the final. Oh, that's cool. That's cool. What explains why you hate graph theory? Graph theory is the best thing in this class. Honestly, it's incredibly useful, and you just have to. The reason why I've done so many programs with you on it is because you have to learn that pattern of graph traversal. Small brain Python programmer. Yeah. Okay. So there's various ways of doing correlations. This thing called an R value shows how much one variable correlates to another variable, right? And so competence exams had the highest R value of all the things that I did. So I'll run that again this year and see if it still holds true in CSI 26. All right, import graph theory. So you're going to be Combinatorics take 3. Yeah, it'll go up to at least 3. I don't know if I'll do 4 of them, but at least 3. Okay. So let's talk about the programming assignment. Looks like about half of you guys did it. All right. Did half the class just leave or something? Right. So basically, the key thing here is just this, right? So you start off by my code copies all of the locations out of the graph for you, so you didn't have to really know much about the bridges stuff. I'm not going to show all of it because some of you might last chance this, but I'll show part of it. I know you're curious about it if you got a 0. So, so basically, for every vertex in the graph, that's what this code's saying. Then we add that to the locations vector. So I'm basically just copying out of the graph all of the cities. And so LOC doesn't stand for Library of Congress here, it stands for a location. And the thing sorts like this. where if the two longitudes are the same, you sort by latitude. Otherwise, you sort by longitude first, basically. And so basically a location is just a latitude and longitude and a name associated with it. Okay. So in place back here, some of you might not be familiar with that. It's the same as pushback, except what happens is rather than pushing a location, you push the arguments to the constructor. And C++ has something called argument forwarding. And so what happens is that these, it's going to add to locs, and it passes the parameters to a constructor. And the reason why we do this is because if you don't do this, what you do is you would create a new location. Like if we were gonna do this with pushback, what we would do is where's my we'd be like locs dot push back b. Is that correct? No, that can't be right. Locs dot pushback. Taking a location. Okay, let's do this. Location temp, passing in v, yeah, it's basically this, right? That passing in temp. Okay. So basically these two lines here are the same thing as this one line here. Okay. And what's happening is we're creating a new location, passing in the latitude and longitude and the name. Oh, right. V is not the vertex. It's just the name. Right, because in the graph is indexed just by the name. So this is getting all the keys, not the values. Okay, so it's going to get all the keys, all the names of the cities, and so the first parameter here is the city name, and then it's got its latitude and longitude here. And so these two lines here are going to construct a new location. And so what happens when you do this is that it copies in the name, it copies in the latitude and longitude into temp, and then when you do a pushback, it copies the values from temp into the new value in the vector. So it's two copies. In place back avoids one of those copies. So, in place back does what's called argument forwarding. So rather than a function call getting past these three things and then it copying those three things, then copying them into the vector, it does what's called argument forwarding, and these things go directly into the constructor of a new element in locs. So locs here makes new room in the vector, and these three values get forwarded right into the constructor for it, and so it constructs a new location in place in the vector. It saves you a copy. It's more efficient. If you look at the running time, in place back should always be at least as fast as pushback, and depending on how the optimizer runs, it should always be either faster than or the same speed as pushback. I did see a benchmark once that showed pushback being faster, which I found interesting. I went to a conference and was talking to a guy who made a static analyzer. It's called Tomato something. I don't know. So So his static analyzer would flag any time you have pushback, it would flag it and say you should use in place back instead. And so I talked to him about that. I was like, I just saw a paper the other day that showed that it's sometimes slower to do in place back. He's like, what? That shouldn't be possible. And I'm like, I know. He's like, do you have a copy of the paper? And I'm like, I'll try to find it for you. And I was sitting there scrolling through my bookmarks and things like that. And I couldn't find it for him. So I'm like, I don't know, dude. I don't know what to tell you. I agree. It shouldn't be slower, but this person made posted an article benchmarking it, and sometimes it was slower. So it shouldn't be though. So you should, generally speaking, try to use in place back rather than pushback. Whole tomato. Yeah. Mm-hmm. Yep. And so what's cool about it is that you can it'll basically go through and find code inspection modernization, code issues in the editor, quick fixes in the editor. Yeah, so you can right click and it changes your for loop into range based for loop, and so that sounds exactly like the person I talked to. Where was that though? Was that? Yeah, it had to be GDC. I kind of want to say it was CPPCon, the C++ convention, but I'm pretty sure it wasn't. I think it was at GDC, and he was selling. Maybe it's because like that thing there said that he has some sort of Unreal Engine support. But so I kind of nerded out with him over C++ for a while. It's kind of fun. He's a real smart guy. I messed around during one of my shifts and proved that print is faster than cout. Yeah, can be. Especially if you use endline. Endline's not fast. Endline, ENDL, is not something you want to use if you care about performance. Yeah. So, in general, rather than doing that, you're going to do that instead. Okay. This is actually faster. The reason for that is because an inline not only prints a new line to the screen, it also flushes the buffer, and it also synchronizes the buffer with the C library output buffer. So in C we have these things called like Printf and things like that. And it's got its own output buffer, and so if you do inline, it synchronizes the output buffer with Printf, which is not fast. And if you're just doing that on every line, like, oh lord, you're flush, it's doing a flush every time. Yeah, you want to do this if you care about performance. Okay. Mess around. C. Yeah. I kind of want to say there's nothing wrong with Printf, but that's not true. Printf has issues. It is not a. I kind of like Printf. Let me show you. No. Scenario.h. So you'd say printf, hello world. Got hello world. Now the way that printf works with variables is you have to put the variable in here like that, and what you put like this has to match the type of this, and Lord help you if it doesn't match, or Lord help you if you put in an extra symbol without realizing it, right? Or if you get the formatting wrong. Like I say print a double and I give it an int, and instead of getting 42.0 I get garbage basically. Okay. Right, so you got to be real careful that everything lines up right, that you have the things in the right order. If you come in here and put another thing in, then the order of arguments here have to match, and you have to be real careful that the types match and things like that. And you got to learn all the different things, right? So like if you 42.5 so if you screw up the typing, if you try printing more things or less things than there are, it explodes, right? So like, let's try printing an integer in a float and not pass anything on the stack to it. It's a warning, it's not a compiler error. See that? So cout has a lot of things going for it. The nice thing about Printf is you can make very compact things. You don't get at what is called chevron hell. Like if you're trying to print out a lot of variables, you end up going double left arrow, double left arrow, double left arrow, double left arrow, double left arrow. So there is something called the format library that is kind of like the best of both worlds. And this is new in C++ 20. It was based on a library called FMT, which is slightly different. So you can call format like this, and you can put you can embed these things like that in it, and you can put numbers in it too to indicate which parameter it is. And so you can essentially do a printf, right, where you have variables embedded within a string, which allows you to make a more compact output statement. But it's type safe, and it's also more performant than either printf or cout. So that's kind of a new thing. For one-liner, printf's the way to go. What's the buffer? What do you mean by what's the buffer? Oh, the output buffer in so there's a input buffer and there's an output buffer, right? And that's right. So when you have the keyboard, you know, you've got your clickety clackety keyboard here, right? And you type in hello. What happens is that there is an input buffer, and it's going to look like this. And presumably a new line character after that. So if you type in hello and hit return, then it goes into a buffer like this. And so you can pull things out of the buffer one character at a time using cn.get. You can pull it out a word, which will read until the new line, and not read the new line. It reads until the new line if you do like cn into a string. What cn into a string does, like if you have a string s, is that it reads the h, the e, the l, the l, the o, and it leaves the new line here. There's also cn.getLine, which or getLine cn s, that's the way I usually write it, and that will read everything from the input buffer until a new line, including the new line. And so in this case it would be hello. In this case it would be hello also. But if we had like a white space there or something, this would be different. Like if we typed hello world, this would only read one word. This would just read the H, and getLine would read hello world, right? Read one word at a time, read a sentence at a time, read a letter at a time. These are your three basic ways of reading things in C++. And it can be tricky if you mix and match them, as I'm sure you guys are well aware by now, because getLine reads until a new line, and cn double right arrow will read until a new line or white space of any kind and leave it behind. And so if you do a double right arrow followed by a getLine, a lot of times it'll do this, leave the trailing new line in here. You do a getLine, it returns an empty string, because there was nothing before the new line. So the output buffer area is the opposite. So when you print things to the screen, it actually doesn't go immediately into the screen. So if you were to cout, it's a horrible cout. If you were to cout hello with no new line or anything like that, then it would go into the output buffer, H, E, L, L, O, and no new line or anything. And then if you cout again, world, then it'll keep writing into the output buffer. It doesn't actually appear on your screen. Okay, it doesn't appear on your screen until you do a inline. Okay, inline will flush all of this. All of this then appears in PuTTY. Okay, or it'll flush if you do a cout \n. Inline always flushes. \n flushes, which means the output buffer actually finally appears on the screen. If a console, and this is a very subtle bug that has burned me in the past, because I would cout things with \n because it's faster, right? And then my code would crash, right? Back in the days when I wrote code that crashed, right? And the string would not appear, right? And so I would put all these cout statements into my code, and it'll flush if you're running it interactively, but if you are outputting to a log file, it doesn't appear. This isn't Printf. This isn't Printf. This is cout. So if you're writing to a file, this does not flush. If you're outputting to the screen, it'll appear immediately. If you do hello world \n, it immediately appears on the screen. If you do hello world \n and you're writing to a file, it does not immediately appear. It gets put into a buffer, and it does not flush until you call either inline or you call cout.flush. Cout.flush dumps it all to disk or this console or wherever it's going. Okay. And so if you really want to make sure that your stuff doesn't vanish when you're writing to a file, you want to either do a flush like that, or you want to do an inline like that. But if you care about performance, you don't. So, because flushing's it has to sync the buffer to disk, and that's not cheap. And especially if you're doing something like this here, where you're just saying for every element in the vector output at the screen, you want to use \n, and if you're worried about it not appearing in the like if you were to redirect this to a file or something, then you do a flush afterwards just to make sure, absolutely sure, all that stuff will get put on disk. So if your code is crashing down here, which it might, you don't lose that data. Okay, but as long as you're couting to the screen, then you don't need this. This is only if your console output, which normally goes to the screen, is being redirected to a file, which is possible. Okay, so upper hole, I start off by adding, so I sort the vectors from left to right. So the westmost is at the beginning, the eastmost is at the right. I start off by adding the first two cities to it. So let's say I've got, some cities. Like that. It starts off sorting it left to right. And so we have A, B, C, D, E, F, and we start off by adding these two cities to the output, to the whole. Okay. We then have this loop here, and it's very similar to the sample code that I gave you, right? except some of you didn't understand what was happening, and so you didn't have your code running correctly. So the cross product of 3 cities tells you if it's a left turn or a right turn. So we've got these 2 guys in the vector, and then we're going to see, is this a left turn or is it a right turn, right? And so the cross product of city 1, city 2, and the new city will give you a positive number if it's a left turn. So this will be a positive number, and it will give you a negative number if it's a right turn. Okay? And so what you need to do is anytime there's a left turn, you need to essentially delete this person from the whole and just do this instead. All right? Is the order of parameters in cross product important? Yeah, because if you do it in the opposite direction, you'll get the opposite number. All right? So it's 0.1, 0.2, 0.3. Those are the 3 parameters to cross product. And if you do it in this order, 0.0, 0.1, 0.2, if you get a positive number, that's a left turn, and then you have to pop this person off the list. So while the cross product is positive, I just delete the person off the because I'm building up a vector of all the people in the upper hole. Okay, and then if I ever dip below 2 people in the upper hole, I'm done, because you can't ever have less than 2 people in the hole, right? So I detected a left turn here. This guy gets popped off. I now am down to 2 people in the hole, and I'm done with that processing C. Okay. I then move on to the next one, and so you just add each of the nodes one at a time as you go left to right, I actually don't push back unless until I'm I don't push back until I'm done with all the pops, just so I don't have to constantly push it and pop it off the stack. So I just sort of tentatively check, right? So I'm checking upper hole, 2 back, 1 back, and then the new guy. So these are 2 different vectors, right? And then the new guy gets added to the upper hole if he's, well, every time, actually. So the new guy always gets added to the hole. So then we add the next guy to the hole. This is a right turn, so it's fine. Move on. We then add the next one. We add the next one to the hole. And this is a left turn, right? So if you're looking at the vector here, the guy 2 back, the guy 1 back, and the new guy, the guy 2 back, this one, 0.0, 0.1, 0.2. That's a left turn, so that's a positive number. So while we're getting a positive number, we delete the previous guy, and we keep doing that. So we might end up in a situation where you pop this one, you pop this one, you pop this one. You might go all the way back, like if you had a point up here or something, like you would end up popping, 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 all the way back and just ending up with 2 guys, possibly. Okay. Yeah, so let's add this guy in here as F. Give this guy's G. All right, but here we found a left turn, so we pop this guy off the upper hole. So that guy gets popped off. And then we now have a right turn, so we're good. We then try this guy here. That's a left turn, right? So this guy gets popped off. He gets popped off. We try again, right? It's a while loop, and that's still a left turn there. So C gets popped off the hole. Okay. And now we're down to 2 points, so we're done. We then add G, that's a right turn. The first point and the last point are always going to be in the hole, by the way. And then we're done. So that's the upper hole, okay? And that's going to be done in red, I think, or maybe it was blue, one or the other. And then coming back the other way, you just do the same algorithm, just coming back the other way. And so that's it. That's basically the whole algorithm right here. Okay. That was your homework assignment. Okay. So Yeah, you can. If you didn't use your last chance, you can use it for extra credit now. Yeah. Okay. Clean that up. No, it just means you did well. Okay, so that was the last Bridges assignment, and then you have to like visualize it and stuff like that as well. All right. It's a good algorithm. It's a good test of your programming skills, I would say, and is also kind of vaguely graph theory ish. You're operating on a graph and visualizing a graph, but you're wrapping the graph in a whole. So. So you end up with something like this, where you end up having, the red is the upper hole, blue is the lower hole. You mark as purple the points where they come together, and so they're not flat, which makes it look a little weird. I'm going to see if the Bridges people can make some straight edges for us so that it actually is a convex polygon, which is what a convex hole is for. But it works. So that's what we want to see as your output for the assignment. And what can you do with that? Okay. Graph theory is the brick in your window. You never knew you needed it. It comes up all the time in computer science. And when you get job interview questions all the time come from CSI 26, and a lot of them are graph theory questions. So if you didn't get it, you just need to keep working on it until you get it. I posted a link a couple days ago on A-star that's got a nice visualization of A-star and things like that. Okay, so let's talk about the code tennis. So that was also I guess technically we got time for one more graph theory programming assignment in the semester. Good idea, Betancourt. Thank you. All right. So let's take a look at the let's see. Looks like almost everybody did this. Nope, some people didn't. I guess it's unfortunate. It's not a hard assignment. Looks like most of you did it though. All right. Yeah. So the idea is you just make a random number generator. All right. It's not anything hard. And the second half of this assignment is that you are going to use other people's random number generators, and you are going to essentially try to figure out the distribution they used. Okay, so don't cheat, don't share the numbers with each other, but I'm going to post a couple random number generators of my own. And it's your goal to see if my random number generator is different from some of the students' ones. So, that's funny. Okay, so let's try running one of them. temp/Vargas1, and so it generates a ton of numbers. Vargas2 generates a ton of numbers. Vargas3 generates a ton of numbers, and I've got Vargas's stats, for example, and I might post a couple of my own, and it's going to be your goal to see if my code is the same as Vargas's code. And you did the edges backwards. Yeah, it's fine because it's a straight line, right? It's a straight line. It shouldn't curve at all, but that's just how they visualize the lines. A convex hole is a convex hole, and so you probably did it using the code off that website that I gave you, which They do it counterclockwise. I do it clockwise. It just works easier on my brain that way. If you confused the clockwise and the counterclockwise, then your code wouldn't work. That was what I wanted to see if you could figure out. Okay. So, like, I want to see that you understand the stuff, not just sort of blindly copying code, but like, why, why is my code not working? I'm accepting left turns, but I'm not accepting right turns. Why am I not getting all the cities or whatever? So, yeah. So what can you do with a convex hull, right? So you come back the other way, you're going to end up with the blue hull looking like this, that, I guess. And so what you end up with is a loop like this. And as always, if you're segfaulting, the first thing you should jump to is add this to Betancourt's. Always remember that. If you're ever segfaulting, if you ever do anything going out of bounds, anything with memory, always add that first step. Make sure you have debugging on too. But always turn on address sanitizer. And when your code goes out of bounds, it'll tell you. Right? So that's crucial that you guys should know how to do that. It seems to work. It's not doing the visualization. All right. But yeah, if your code segfaults, it'll tell you what you did wrong, right? You have to look at it a little bit, but it'll basically say you went out of bounds on line 54, or you used memory after it was freed, or you dereferenced a pointer that the thing pointing to isn't there anymore. Whatever. Like it'll give you a good error message. There's a lot of detail on it, and you need to kind of focus on the parts that's your code, because it'll sometimes say on this line of the standard library, you're like, no, ignore all that. You want to find where it's your main.cc. Okay, my main.cc line 27. Okay, that's where the problem is. And now sometimes that's not where the problem is. Like you'll allocate memory on line 27, and then you forget to deallocate it, and then it'll say memory leak. You allocated memory on line 27, you never freed it, and so the error isn't exactly an error on line 27. It's just like, hey, by the way, that's where you did a new, and you don't have a matching delete, right? So you have to, like, this is part of the training process that I'm trying to get through to you guys, is that you need to be able to look at those kinds of things and diagnose and solve and stuff like that. So I don't know this Python has garbage collector. There's no garbage collecting in C++. But address sanitizer tells you whenever you do something wrong. It's way better than in the past where things would just sort of silently fail. I feel like G++ should turn on by default. It does. If let's become Betancourt again. Alias G++. I have an alias set up for you guys. So if you type G++ by itself, it turns on all warnings, and then more warnings than all warnings, and then pedantic warnings in addition to all warnings and extra warnings. You're like, wait, why isn't all warnings? It's not. All warnings is not all warnings. There's more warnings than just all warnings. Pedantic errors, so that turns pedantic warnings into errors that don't compile. I disable warnings for unused variables and unused parameters, because who cares? Like if you make a string or something, you don't use it. Like, who cares? I mean, like if I was going to release production code, I would care. But while you're doing development, it's quite normal to have some function parameter you haven't gotten around to using yet. So it just irks me to see those warnings constantly when I'm doing development, so I turn it off by default. Compiling by default in C++ 20 mode, compiling with debugging information included. Again, you want to turn that off before you do your final release. I set fmax errors to 1, so it stops after 1 error. Because usually when you have 1 error, like you mistype a variable name, it's going to throw a lot of errors. Instead of int x, you typed int z or something, and you use x 20 times down below, it's going to throw a ton of errors, right? So I set max errors to 1, fatal errors, so it stops termination. It terminates compilation immediately, so you don't get 900 pages of error messages. I use the debug standard library. The debug standard library does bounds checking. Even if you use square brackets on a vector, it'll bounds check. Ah, that's cool. So that's a little known option, actually, that a lot of people just don't know about. So with the safe standard library turned on, it will check even if you do a square bracket. That's not true if you use C-style arrays. C-style arrays won't bounds check because they're not part of the standard library. But anything in the standard library, vectors, square brackets that don't bounds check normally, it bounds checks. Hey, that's cool. Turn on UBSAN, undefined behavior sanitizer. So it checks for things like integer overflows and things like that. And address sanitizer. So these are the compiler flags that you should always use, in my opinion, when you're doing development, especially as a new programmer. Now, why is this not on by default? Because it actually slows down your compile times, like substantially. It slows down your compile time, and it substantially slows down your runtime. So it's not the kind of thing that you always want to have on. You know what I mean? Like if you were G++, Mr. G++, you're not going to put it on for everybody because it's a substantial penalty. But I turn it on for you guys by default because it's nice, right? So happy birthday, by the way, Bencourt. So there's a deallocator program you can build to deallocate memory. Deallocator program? I don't know what you're talking about. I'm not piling on you. This is the same alias that everybody's using. I'm just going through the default flags here because this is the last class, and some of you guys aren't going to take me for 45. Shahab, for example, is taking 45 right now. And so when Shahab graduates and presumably goes to some 4-year college after this, they're not going to have this. Nobody knows about this, apparently. I don't know why. I don't know how. But my students go to Berkeley, Irvine, UCLA, UC San Diego, whatever. None of the professors know about this, apparently. I don't know. I'm sure some do. I don't know. But none of them do. And so that's why I'm going through this right now. So take this with you. Hazelton made a meme of the link, the wooden sword. Here, take this with you. And it says -f sanitize equals address. It's this right here is the single most important thing to take with you when you do C++ at other institutions. Okay. So, you tell your coworkers that really they can't handle CSI 26. You can handle it. You can handle it. We all just know about Nick Muya. So what's the command to edit the aliases again? So my aliases are all set up. If you type VC, it's an alias. I have an alias set up to edit the aliases. So I use the alias to create the alias. Okay. And this is all the aliases that I've built up over the years. And so this .cchrc file that I have for you, when you go to other institutions, they're probably going to have you use bash instead of tcsh. I use tcsh in part because of my aliases file that I've built up over the years, and I've got things like completion. This is a tcsh thing very specifically here, and I just don't want to have to re-implement it in bash. That's all. Bash is completely better than tcsh. There's absolutely no excuse for using tcsh in this day and age. However, because I've built up this large .cshrc file, I still use it because I've actually been working on this file for 25 years now. So I make changes every year to it. So there's probably some stuff in here that, nah, I guess it's, yeah. Netscape communicator. There's a word I haven't heard in a long time. Lord. Yeah, so, yeah, that's from 97. Yeah. The real audio player. Yeah, for real audio support. Wow. Yeah, that's a bit old. Is there a difference when doing aliases between the three, between Bash, tcsh, and Z shell? No, I mean, they all support them. It's just the formatting is different, right? So if you use Bash, Bash has aliases as well. It's just the way they're set up is, like if you do completion, like if I typed complete, you can see that they're all set up differently in Bash, right? With different flags and things like that. And I just don't want to port it. That's all. Just me being lazy. There's really no benefit to TC shell, but at the same time, there's no benefit to Bash. What? Huh? Bash is better. Yes, it is. Check this out. So let's say that I want to do something like roll a random number, right? In Bash, if I was in Bash, I could echo random like this. Anything in Unix shell scripting with a $sign is a variable, right? So I could like set a equal to 5, and then echo a. I don't remember the syntax on it, but when you jump between shells, the syntax changes. So you can just set a variable and then echo it, but the $sign indicates it's a variable in Unix shell scripting. And that's the same between all the different shell types. So Bash has a variable called random, and if you echo it, it rolls a random number. TC shell doesn't have that, right? So, why did I say there's no benefit to using Bash? Check it out. Here I have a TC shell script, and I call Bash. Bash-C says bash-C, echo hi, and so that runs Bash and does whatever I tell it to within the single quotes. So I can just invoke Bash and have it run, give me a random number. Thank you. So despite TC shell being dumb and not having support for a lot of things, because it was written in the 90s, and not developed really since then, I just invoke Bash and just use it whenever I need functionality like that. So, is there speed boost? Yeah, I mean, so like the most obvious answer for why is it better? It's like if you run a program like that, right? You can redirect the output into another program, right? In TC shell, you can redirect the standard output and the standard output and the standard error together. You can't do it separately. In Bash, you can. That's the single biggest feature I wish they would add to TC shell, which would be the ability to like dump standard error to dev null, right? If you redirect something into dev null, redirect into dev null, it vanishes. It's the trash can essentially. Any bits redirected in there vanish. And so in Bash, you can say redirect the standard output, something like this. You can say redirect the standard output into dev null, and pipe the rest of it into cat. And you can't do that in tcsh. That's the single biggest feature that I wish tcsh had, right? You can. I'll show you how I hack around that, and it's really garbage. But ambiguous output redirect. Yeah, tcsh has no ability to split it like that. Pool allocators. Yeah. So that's a very common technique in game development. Like even if you look at like Quake 1, they use essentially a pool allocator. So you have a chunk of memory, and so rather than calling new and delete over and over again, you never do. What you do is at the start of the program, you allocate a chunk of memory. It's got enough room for 500 actors in the entities in the world, and then every time you use something, you just find the next open spot, and then that's the next entity. That's where its memory is. And so doing custom allocators is very common in video games or anything that needs high performance, because new and delete is slow. Well, you're getting a Unix class now. There he is. There's a whole bunch of like special variables. Like, so this is how many command line parameters I passed in. And so if I don't pass in any command line parameters to it, if I just run random student like that, it'll tell me how to run it. Like, oh, you didn't run it right. Okay. So I'll pass in CSI 26, and it picked out different people every time. Okay. So if I want to call on somebody, I can do that. So then this tells me how many people are in a class. So WC is word count by line, command line parameter 1, and then it cuts out what does that do? Word count line, this is like 26. Yeah, it cuts everything before cuts out everything after the space. So what I'm doing is I'm counting how many lines are in CSI 26, the file. Then I cut out everything after the space, so it just gives me the number. And then I do a modulus. So I generate a random number, modulus by the size of the class, add 1 to it to generate a random number from 1 to 20 students or whatever. And then I use head and tail to pick out that line of the file. And so this is a Unix shell script that randomly selects a student from the class. I probably could have written it faster in C++ because it's not hard, but I like Unix shell scripts. They're fun. My Unix class was probably my favorite computer science class, honestly. Like it really was useful, because shell scripts allow you to knock out very complicated programs very quickly if there's a Unix utility that does what you want. So for example, is there a Unix utility that counts how many lines are in a file? Yeah, word count. So if I were to just word count CSI 26, it'll give you words, paragraphs, lines, paragraphs, lines, characters. Yeah, something like that. Lines, words, and characters. Yeah. Lines, words, and characters, and each line is one word, so those are the same. And then the file name. And so I could word count all the files in here, and it'll tell me, the relative thing. The parse web advisor is a program, so we can ignore that. But like my biggest, like if you want to see which one of my shell scripts is the biggest, right? So I could say word count star.sh. Word count all of my shell scripts in this directory. Cool. And then let me pipe it through sort. And that's sorting it alphabetically. So if I want to sort it numerically, I type man sort. And I want to do a general numeric sort, maybe. That sounds maybe good. Human numeric sort. No. Numeric sort. Probably just numeric sort. That's the one I've used before. So I sort it numerically like that. And okay, that's least to greatest. So maybe I want to do it reverse sorted. Reverse is -R. So do you guys see how this process works? Like you just pull up the man page, you look for the flag that you're looking for, add it in. That's what I want here. Cool. So that is my biggest shell script there. And if I want to ignore, if I just want to see like the top ones, I could type the results of that through head. And then that's the top 10 lines. And then I can do head -5 and just get 5 lines out of that. And if I want to drop the, that line there, because that's the total for the whole thing, which I don't care about, I could probably word count. No, maybe word count doesn't have the option to do that. So then I will type it through tail -4, and I get rid of the top line out of it. And if I just want to have the names of the files, yeah, the Unix class isn't anytime soon. You're talking like a year and a half out. I'm sorry. You're getting the gist of it right now, though. Just rewatch the video if you ever get confused. And then if I want to just have the file names, then I can pipe that through cut. Cut pulls out columns of things, so I can cut see column 4. Okay, delimited by spaces. It's unfortunate. Normally it cuts based on tabs. Yeah, unfortunately there's not an even number of spaces in these things, which is kind of annoying. Yeah, so let's just do field 1 then instead. Field 2. Oh, it's got leading spaces too. That's annoying. That's super annoying. Field 3. There you go. So you can see some of these are coming through and not others. Yeah, it's annoying when things are like pretty printed like that. Normally, what you do with cut is when you've got tab delimited data, you can just, like a CSV file or something like that, you can just use it to very quickly select out a column of data from like a CSV file or a tab delimited file or something like that. It's super nice and convenient. So, is there a book on Unix? Yeah, I mean, there's lots of books on Unix. I've got tons of PDFs. The one that I learned on is actually this one, which I bought used from the UCSD bookstore ages ago. But basically, it's got these sections here at the back where every Unix utility has a page, and sometimes extra pages as well. And so, like, if I wanted to look up cut, cron tab, is there no cut in this one? Interesting. Yeah, basically all the major Unix utilities, like tail is here. Yeah, and then it gives you explanations of the command line parameters. Then it gives you tons of examples of running it and using it and stuff like that. And so what I do is just every day I just open it to a different page and learn one Unix utility. And this is the Sobel book, Mark Sobel. You can see how old it is based on the cover. But there's probably more recent things that are better than this. But that's what I learned on, and I still have it because it's actually still a good resource. Back in the shelf with you. All right. So, Udemy courses if you want. Yeah, sure. Yeah, so you wanted to see my collect homework? I have lots of notes myself, by the way, too. These things are setting variables, so all the command line, anything that needs to be configured, like if I ever go to a different system, my user ID and my group ID probably are going to be different. What directory it collects homework into, the maximum file size. So if your code goes into an infinite loop, it detects an infinite loop by saying, did you write more than 10,000 bytes, to the screen? And for some homework assignments, like you actually do write more than 10K, so that's a tweakable parameter that I can override. Permissions by default here, and the UMask is permissions, default permissions. And how long do I give you to run your program? 3 seconds. So you've got 3 seconds for your test case to finish. If it doesn't, it kills it and moves on. I check to see if a program called do alarm is installed. If it's not, then it uses GNU timeout instead. And so I've got some clever things in there that uses an executable. If it doesn't find the executable, it uses a different executable. Instead, it finds out if I'm root. If I'm not root, it won't run. Checks to see if I have enough command line parameters. If not, it tells me how to run it. And this is all code for me. I technically don't need any of this, but if I ever forget, then it reminds me. I do all sorts of sanity checking. I don't trust myself, to not type a semicolon in a text file or something like that and just break everything. So I sanity check the hell out of everything. The homework name, the class name. I open up the class. So like I'll open up the class in the script and go through it, and if there's any special characters in there like semicolons or quotes and things like that that would break the script, it dies. It's like nope, fix your text file. So I wish I don't trust myself as a classic programmer quote. I wish more people did that, because a lot of them will just be like, well, I'm not going to type something wrong. I'm not going to have any single quotes in the list of students in my class and the file for the list of students in my class. Why would I do that? And then you end up copy pasting something accidentally one day, and there's a single quote in there, and then everything explodes, right? And when you're running something as root, you really want to be cautious with it. So the way that the autoreader works, I check to see if the directory exists. If it doesn't exist, then it creates one. So I go through it creates a whole hierarchy of every class has its own directory. If that doesn't exist, it creates it. And you can see I'm here cutting. I'm cutting that cuts out columns of data, and I'm cutting everything before semicolons and spaces, and checking to see if the only names allowed are letters and underscores. Right? You can't have any special characters in the names of anything. So this is all sanity checking. Like I haven't even gone to the collecting yet. I'm already 173 lines in, and I'm still just, checking, hey, do these exist? No, they don't. Okay. Does this exist? No, move on. Does this exist? No, creating it. Does it exist? No, creating it. And so it's doing a huge amount of sanity checking and building directory structures that know it exists, and then we finally get down to actually doing the grading. And so this is a for each loop. So this is a range-based for loop, essentially. And so I'm saying for every student in the class, and again, I am cutting out any semicolons, spaces, anything that's not an alphanumeric and an underscore gets cut. So I'm highly paranoid about running anything as root, right? And so I check to see if you exist, because I could delete you out of the server, and even though even though the text file says Aaron exists, if I've deleted him, I need to check on that. So student, Aaron doesn't exist. All right, cool. So and I check to make sure that you're not a system user. So if you're me, for example, it doesn't run on it. And then it gets into the actual grading. It sets your score to be 0, and then it's going to copy all the files over, and this is the trick that I use for redirecting standard error that I was telling you about. Parentheses like this runs it in a subshell, and so I'm redirecting everything from the subshell into dev null. So standard out, no, I'm not doing that quite yet, but I copy all of these files over into the source directory. If you got a make file, I build it using make, and I do everything as you. Everything gets built as you. So if you were to submit a homework assignment that was like, delete all the files in the server, you have no permissions to do so. You know what I mean? I do not run your code as me. I do not run your code as root. Your code gets run as you. Sudo, as you, build, do a make clean, do a make. Okay? Not even the make file, because the make file can actually have horrible stuff in it as well. So when I run make, it runs as you. When I run G++, it runs as you. When I run your program, it runs as you, you know? And so the heart of the program is going to be right over here. So I run the program as you. And this is the trick that I was telling you about. So running it in a subshell, I redirect the standard output into a file, and then I redirect the standard error into dev null. And so even though tcsh doesn't support separate redirects for standard out and standard error, I figured out a way around it. So who cares about bash? Okay. And the other benefit I like about tcsh is that it looks like C. Like the C shell was made to sort of emulate what C looks like, right? Doesn't this look kind of like C to you? I mean, there's a then and an endif, but it's pretty close to C. Whereas bash uses square brackets for if statements and things like that. And I don't like having to mentally switch back and forth between C++ and shell scripting. And so C shell, which tcsh is a variant of, looks a lot like C. It uses the same constructs and things like that. That's why I use it. So then I run your program, I run my program on the same input file. If your output is too big, then that's an infinite loop, and you don't get a point for that. If my thing runs into an infinite loop, then it's like, bro, what are you doing here? You know? And I mock myself if my code falls into an infinite loop, you know? And then I compare your results with my results. That line right there is how we determine if your code is correct. Okay. So, yeah. So if there was a difference, then diff returns an error code if there's a difference between the two files, and then you're wrong. Otherwise, you got it right, and all the results get logged into a file, and then that gets emailed to you at the end of the day. So it's a big word count line. Select homework. It's 508 lines of shell scripting. It's the biggest shell script I have on here, as we just found. So shell script, super useful stuff. Well worth learning. Okay, so knowing how to format CSV files with Unix would have been really helpful. Yeah. Cut field 1 delimited by commas. That's how you do that. So, okay, CSV. Oh, there's Pokemon. All right, Pokemon stats.csv. Right. So here's stats for Pokemon, various sorts. So if we cut field 2 delimited by commas, then it pulls out column 2 of this CSV file. So real easy, just like that. You can just select columns of data. Paste allows you to put multiple columns of data together. There's all sorts of functions and Unix utilities for manipulating text. And then if you get into more advanced stuff, there's stream editor, awk, which you can write scripts that will modify text and things like that. Sed is stream editor, so it's actually a programmable text editor. It's a non-interactive text editor. So ed, by the way, is what Vim came from. VI is a visual interface for ed. Ed was the original text editor. And so ed main.cc. Let's go to line 2, line 3. Do you see how this works? Line 1, you give a VI command, and then you can say, insert, edit, whatever. It's a text editor that you edit one line at a time. You don't see the whole screen. You see one line at a time, and that's because this was made in a day when you would have like a teletype machine or like a printer. You go, so you'd say jump to line 50. It's like jump to line 40. And so Bill Joy, who founded Sun Microsystems, made VI, which was visual mode, where you can actually see the things on the screen. It's amazing. And he kept the commands from ed, right? So VI is a visual mode interface. Vim it's basically replaced it, but I don't even know if I have the original VI installed in here. But yeah, it was a visual interface to ed, and so sed is a stream editor. So it's a programmable text editor. So you say do these manipulations on a text file, and so it goes one line at a time, and you can manipulate a text file interactively or non-interactively, programmatically on it. So yeah, so your homework's going to be building a shell script? Not at all. So your homework is going to be doing statistical t-testing, okay? So let's go ahead and take a 10-minute break because we're already due for that. Then when we come back, we're gonna finish out the semester by talking about statistical testing a little bit more, okay? And Betancourt wanted me to talk about the difference between a population sample standard deviation and a full sample standard deviation, and we'll talk about that too. So let's come back at 11:40 and finish strong. You're down to skip the break? Yeah, I'm fine with that too. Skip it. All right, sure. Okay, so I wonder if I still have that website up. So no, I don't. In years past, I did an assignment where I made a website and it would pretend to be growing tomatoes, and it was your job to find out if it was doing anything. And the trouble is, students figured out that because the web page has to be world readable, they just opened up the source code for the web page here on the server, and they saw the code that was generating the random numbers. So this year, you guys are generating the random numbers, but let's pretend they're you're doing a science fair, right? Do you guys remember that? Middle school or whatever, the classic science fair project is you're growing tomatoes, and you've got some fertilizer or whatever, and you want to see, does the fertilizer do anything? Right? You guys understand? Does the fertilizer work? And for an 8th grade science fair experiment, you might get like 10 little styrofoam cups and put a little soil in them and put some tomato seeds in, put a little water on it, and you let it grow for a couple months, and then you measure the heights of the tomato plants, right? And so after 2 months, how tall are the control group? How tall are the experimental group? And you want to see, did the fertilizer work? Okay. Because KCUSD, what's KCUSD? Kansas City? Kings Canyon? Kearney's Castle? Kings Canyon, yeah. Yeah, it's interesting to see how school districts prioritize things. My district, which was San Diego Unified, which is not the world's greatest school district. Most of the large metropolitan school districts, I have major issues with, for various reasons. A lot of times, smaller school districts, there's better local control over what you want your school district to do, and ultimately, yeah, they have to make a decision about funding. And San Diego Unified, the first thing on the chopping block was always music programs, athletics programs, theater. Like, my daughter's doing wrestling right now, and they like gave her wrestling shoes and a uniform. I'm like, what? They give you a uniform? You don't have to buy it yourself? What? What's going on here? Because I literally had to, I literally had to purchase everything, to do sports, and it's expensive, not like football, like maybe they had football gear or whatever, but, I did soccer for 13 or 14 years or something like that, and they never once gave me a uniform. Like, I had to buy my own shirt and buy my own cleats and all that stuff, and it's just a priority, So, robotics team had -5 budget, yeah. Really high school blows $1 million on a football team. They can never win. Small school districts, oftentimes football is like the community. It's like a community social event, right? Like when the local like I used to work in Mississippi a lot, and it was a Friday night, like, and the football team had a home game. They'd invite me out, and I'd go to their local high school's football game, and everybody from the community would show up, and they would tailgate, and like it was a big social event, and we would just sit there on the side of the field and talk and hang out, and drink some beers and watch the local team play football. It is a big part of the community. Anyway, so going back to the science fair thing, San Diego Unified didn't really support science fairs either, but my middle school science teacher was a big believer in it, and so he's like, if anybody wants to do science fair, just come in on a Saturday. Like, there's no official support for it, and do your experiments, and we'll do a little science fair here, and the winner gets to go on to the county event, because it wasn't officially supported. Like, almost nobody did it. Like, who wants to come in on a Saturday, right? So there's only like 4 kids at my entire middle school, maybe 5, something like that actually did a science fair project. And I think he like picked the top 3, and I was top 3 of 5. Yay, check me out, And so then I went on to the county level, going up against La Jolla High School and all these schools where, it's serious business, and their top 3 people from La Jolla, like, I don't know, they got like Jarvis or whatever, functional AI with like robot arms like Doc Ock and stuff like that. I'm like, I put paper in water. That was my experiment. And anyhow, so the point is, you've got your science fair experiment, and you want to know, did it work? Remember, this is the whole point of science. Did it work? And that through stats. Okay, so if you guys don't know what I'm talking about, tomato science fair experiment. This is like your classic science fair experiment, right? Like, you put it together, a little whiteboard like this, and Over time, let's see, tomato something in tap water, warm tea in tap water only. So I think no, tomato juice in tap water, tea in tap water, and tap water only. So they have 3 groups. So the tap water only is going to be the control, and then they're trying out if I can barely see this. What over time they're measuring the average growth of 3 plants, the tiny population sample, and what makes plants grow faster: tomato juice, warm tea, one or the other, or tap water. I think the warm tea is going to grow the biggest because the warm tea is healthy for the plants. The reason I did not pick tomato juice is because it has acid in it, and too much acid can kill the plant. Did they write the hypothesis after they got the results? Probably. That's the scientific method. You get your results, then you write your hypothesis, right? So, program classes, video game design. That's cool. I think that video games are a great way of practicing your programming. I think it's a great way of learning programming because it's fun. Yeah, and your video game was pretty cool, Bencourt. So, label the planters: water, tomato juice, and worm tea. I think that does say worm tea. I don't know what worm tea is. Okay. Here's a procedure. Conclusion: tomato juice plant grew the biggest. Oh, okay. So they were wrong. Okay. Is the most green. Sprouted like a tree is fuller. 31. The fort built a fort on top of the soil to keep the moisture in. 32. Cannibal. The tomato plant got its nutrients from eating its friend because tomato juice. That's funny. Okay, but you see what they did here? Okay. So they've sort of charted out the different populations. And so what if this was actually science? Because this isn't really science what they did here. Although it is kind of funny watching a tomato drink tomato juice. That is actually quite amusing. What they did here wasn't really science. Why? Because they don't have a p-value. A p-value is how certain you are in your result is one way of looking at it. Like I said, there's different interpretations of the p-value, and people get really chuffed if you explain it wrongly. Like, what are the odds this is due to chance? Some people get really upset if you explain it that way, but I don't care. So this isn't actually science they did here because they don't have a p-value. That's the one thing you want to look for when you're looking at a scientific result is how certain are you that these results are actually results and not just a random roll of the dice, right? And so if we wanted to turn this into science, let's say, then what you do is you would go into a t-test calculator, right? Now you actually have 3 groups here, which we will just ignore for the sake of argument. If you're doing repeated t-tests, that's actually bad because you'll start discovering differences when no differences exist. But let's just say there's experimental and control, right? So last time I showed you guys how to do this using the mean, the standard deviation, and the count. Remember, n is how many tomato plants you have. You can actually just enter the data directly, right? So let's say tomato plant 1. So this is the tap water and worm tea. I don't know. That's worm tea, and then this one is tap water, which is the control. And so let's say the plants were 10 centimeters, 11 centimeters, and 10 centimeters. And then for tap water, it was 8 centimeters, 7 centimeters, and 10 centimeters. Okay? So we could go into the theory and the how to calculate all this kind of stuff. I'm just going to say just hit calculate now instead. And it tells you that the p-value is 0.1. So essentially, there is a significant difference, almost. So what this means is that there's a 10% chance that the difference of these two populations was due to just random luck. Okay, Because remember, even if you run the same experiment with the same seeds and the same sunlight and the same worm tea, there's always random variations in it, right? And so what they're doing when you do a t-test is you're essentially looking at the overlap of the two populations, right? Because if you have two Gaussians, you know, they're gonna, every time you measure it, it's gonna be a little bit different, right? And so what you're trying to see is, you know, what are the odds that these two groups are actually different, right? And here you can see there's just a little bit of overlap. Here there's a lot of overlap, but also depending, like if you have a pretty high count, like that's probably going to be significant. Like this is like the n for this is probably going to be like 400 or something, right? So it's probably going to be significant. And so we can go into the equations and things like that. The way that standard deviation works is you take the average, you take the mean, and you difference every point with the mean, and divide by the that's if you have a sample of a population, it's n minus 1. If you have the complete population, it's divided by n. So for small numbers like this, where you have like 3, like this denominator actually makes a big difference. If you've got hundreds of samples, the minus 1 stops mattering. Okay. If you've got n equal to 1,000,000, whether you divide by 1,000,000 or divide by 999,999, you're not gonna see any difference. So there you go, Betancourt. You happy? Whether you divide by n minus 1 or n minus 1 is if you have a sample from a pop. So what does a sample mean? Let's say that I'm going to survey Americans, right? And I call them up to get their opinion on who they're going to vote for president in the next election. That's a sampling, because I'm not calling all Americans, right? I'm going to call 1,000 of them. And so I would divide by, in that case, 999, because it's a sample. Whereas if it was the complete population, it would be divided by n instead of divided by n minus 1. Okay. But the formulas don't matter because we have calculators for that stuff, right? So if we took a few more, like if we just got more data, in fact, I'm just going to type the same numbers again a second time, right? You'd think, oh, this isn't going to change anything, right? It's the same number, it's just twice. Well, look what happens. It's now a significant, highly significant result. Okay. What? But I just ran it twice. Yeah, exactly. The more data you have, the more certain you can be in the result. Okay. Yeah, but for large, if you have a very large sample, then what's really interesting actually is like how much ocean water, like let's say that the composition of the ocean is the same, which is not, but let's just say for the sake of argument you got the Pacific Ocean, and let's just say all the pollution and salt content is evenly distributed, which it's not, but let's just say it is. How much of the ocean do you need to sample in order to be confident that you have a good estimate of how much salt or mercury or fish poop or whatever is in the ocean? What would you guys estimate? Square mile? What do you think? How much of the ocean, the Pacific Ocean, it's big. How much of the Pacific Ocean do you need to sample in order to feel pretty confident you got a good grasp on the salinity level and mercury level and stuff like that across the entire Pacific Ocean? 40% of the ocean. It's like everywhere from like Hawaii to California, you gotta pull all that water out, test it. %10 of the Pacific Ocean? That's a lot of water. Nope. Not even. Probably a square meter. That's about it. Population sampling is really interesting. You actually don't need to have nearly as many people sampled as people think that you do. So like, the more you have, the more accurate you have, sure. But like let's do like a margin of error calculation, right? So, all right. So let's say the population size of America is 300 million. We want to have 95% confidence, which is standard. Sometimes we want, that's 95% confidence is p is less than 0.05, right? So let's sample 1,000 Americans. Look at that. Margin of error is 3%. Just 1,000 out of 300 million Americans. If you do a phone survey and you get 1,000 responses, if the responses are representative, which they're not, but if they were, if you could randomly poll 1,000 Americans, you would have a plus or minus 3% accuracy as to who's going to be the next president of the United States. Just highly counterintuitive, right? Watch what happens if I double the size of America. $600 million Americans now. Still 3%. This is something that people get wrong all the time. 1.2 billion Americans, still 3% margin of error. So I'm only pulling 1,000 Americans out of 1.2 billion Americans, and it still is plus or minus 3%, which is pretty accurate, you know. And for presidential polls and things like that, there's always you can't get much more accurate than that, because a lot of people lie about who they're going to vote for. Are you going to vote for Trump? No. You know, and that's one of the reasons why the polls were inaccurate, was because a lot of people were embarrassed to admit they voted for Trump. So let's make it 2.4 billion. So 2.4 billion Americans, you sample 1,000 of them, it's 3% margin error. Okay. So, you know what I'm saying? Like, it's not, this is not, you go up to 2,000, then it's a 2% margin of error. The biggest surveys do 5,000, usually. And so out of 2.4 billion people, if you just sample 5,000 of them, you're down to 1% margin of error. And so people typically have very counterintuitive ideas of like what makes for a good representative population. Do programming socks work? It's funny. So even if you went out to like, it's just, and that's what I'm saying. Like if you imagine how many trillions of atoms are in the Pacific Ocean, if you just pulled out like a bucket, like of it, that's actually going to be pretty accurate, assuming it's evenly homogeneous, which it's not. If it was, you can just pull out a bucket of seawater and test it and be like, yep, this is the salinity of the entire Pacific Ocean. You don't have to pull out all the water from Hawaii to California. You know, you got more than 3,000 atoms in there, you know what I mean? So, yeah. You guys understand? So, if you're dealing with a study that studies like 10 people, then then you got a problem, you know. And a lot of like preliminary results and things like that will have like 3 tomatoes. You know, like for that science fair project we saw, there's 3 tomatoes. All right, you got 10 tomatoes, 20 tomatoes. You know, the margin of error starts dropping. Got to get 1,000 tomatoes. Yeah, well, that's why science fair experiments, you know, even 100 tomatoes is like not great. But the pot, yeah. Okay. So I'm saying this isn't real science, right? So in order to do real science, you do a t-test, and there's other tests as well as t-tests. I don't want to make you think this is the only test we can do, but there's something called ANOVA, that analysis of variance. But there's a whole classes you can take in the subject. You guys are getting the 2-week version, okay, of it, and so rather than going through all the math and like the theory behind it, my advice to you is to be a computer scientist and just be like, here's the height of my plants, you know, here's my experimental group, you know, and here's my control group, and I want to see, you know, is the difference significant? You know what I mean? Boop. Nope. There you go. Okay. So we're looking for p-values of less than 0.05 normally in science. Like I said, some disciplines are more strict, some disciplines are less strict. Sometimes if you get a p-value that's kind of borderline, they'll allow you to publish anyway. Yeah, stats is really useful though, and it does help if you understand the underlying theory and stuff like that. But for the purposes of this class, where you get the 2-week high level introduction to stats, here, do you guys understand? Like, does this kind of make sense to you? Like, you just punch in the centimeter heights, and you know, you get a number, and it tells you if it's significant or not. Okay. Or if you have the standard deviation, count, and mean, you can just punch it in that way. Depends whatever you have. So yeah, there's all sorts of statistical tests, and then you can do like linear regressions and all sorts of cool things. Betancourt, if you're going to be a stats minor, you definitely need this book here. I actually read this book in the UCSD bookstore. I didn't have the money to buy it, but it's a short book. It's not a large book, and so I actually just sat there in the library and it's 100 pages or so. Yeah. It's got all sorts of tricks that you can use to make your point. Where's the banking one? Yeah, here we go. Yeah. So lying without lying. Yeah, here you go. So like let's say that if you want to show how much money reserves your competing bank has versus your bank has twice as many dollars in reserve as the neighboring bank, right? So let's say they have 500 million in reserve, you have $1 billion in reserve. Do you guys see how they're lying with the graph there? What's the trick they use there? Because they'll sometimes even put like a bar, you know. Do you guys get what I'm getting at? Like how is that lying with statistics? Come on, Paint 3D. Why do you suck so bad? Oh my gosh. I just want you to view an image. It's not hard. Okay. Maybe this will make it more clear what a trick is being used. There's two different things going on here. You guys see what's happening? Is this ratios? There's two different things that they did here that are deceptive. No, those are presumably accurate averages. It's fine. What is so deceptive about this graph, or the graph of the money bags that I just showed you? Doesn't start at 0. Yeah, so the axes, right? 5'4" and 5'5" are actually quite close to each other, right? In fact, we're pretty close to being like a rounding error. But this person looks significantly taller than these people, right? And 5'2" is like way down here, right? And so by picking the starting point and the ending point on your graph, you can exaggerate differences. Like, let's say that your bank has 1.1 million in reserves, and your competing bank has 1 million, 1.1 versus 1. You can make that y-axis have the bottom of the graph be 1, have the top of the graph be 1.1, and you can see what a huge difference there is between your competing bank and your bank. There's another trick. Height does not reflect character height. I mean, it probably does. This is probably actually the actual average height. What's the other problem? As an Indian woman, I can confirm that too much of my time is spent hiding behind a rock, praying the terrifying gang of international giant ladies and their Latvian general don't find me. is the x-axis is also scaled. Okay? So they didn't just scale the y-axis, they scaled the x-axis as well. And so that creates a square effect. Right? So with the bank money, so maybe you guys should read this book if that's not obvious to you. The bank reserves, where was that? Were, look, twice as wide as well as twice as tall. And so the human eye looks at that and says, oh, well, your bank must have 4 times the money of the other bank. Do you guys see that? So even though, you're not lying, like here's 5 million, here's 10 million, because you made the thing wider as well, the bag of money there is actually 4 times bigger than the competing bank. All sorts of tricks. And after you read this book, like you'll see it being used all over the place in marketing and politics and things like that. So, if you want to, if somebody's complaining that you're making too much, if somebody's complaining you're making too much profit as an evil businessman, you put together a chart like that. It shows what a tiny slice of profit you're making relative to the amount of wages you're paying out. There's all sorts of tricks in there. It's use your powers for good, not evil, but that book, which is you can find free, by the way, online. I think it's out of copyright. I think there might even be a copy on the files section there. Is good. It's good for you to know. So here you have the Indian woman who's this wide, and then the Latvian woman who is this wide. So the woman here is like, I don't know, 5-6 times the width, and 1, 2, 3, 4, 5, 6 times the height. So the Latvian woman is 36 times taller than the Indian woman, right? So that's, yeah. Okay. I have other memes, but let's move on from that. Okay. So for your homework assignment, what you're going to do is we're going to pretend that the executables up there are tomato plant generators, right? So when you run /temp/vargus1, these are the heights in centimeters of 100 tomato plants. Okay? And if you're Vargus, you can't use your own. Okay? You guys understand? And I'm going to make a generator called like Vargus Kearney 1. I'm going to pick a couple students. You can pick one or the other ones. So there's going to be Vargus Kearney 1, Vargus Kearney 2, that kind of stuff. And it's your goal to determine if my generator is different from his generator. Are these populations distinct or not? Okay? So I'm the control, he's the experimental group. Did his fertilizer cause these tomato plants to become taller? That's the question. Okay? You guys understand? Means yours is going to produce 600 centimeter tomato plants. Fair enough. They're 60 meters tall. Maybe it's millimeters. I don't know. You know. So it's some measurement, right? It could be flow coming out of a waterfall. And I've since built a dam, and you want to see, has the water flow in the water significantly been altered? Okay, because there's always noise, there's always sampling errors, things like that. When I built a dam on the river, you want to see, did Kearney affect the flow of the water in a statistically significant way? All right. So that's your task. Do you guys know how to do this? Do you think you could do this? It'll be due like on Tuesday or something. A little bit more direction? Okay. So let's copy some of this data into Excel. Are you getting graded on correct guesses? Yeah, not only correct guesses, but you also have to do the, you're actually going to have to do the stats. Okay, so let's dump this into Excel, and then I'll run areas 2, areas 3. Sure, why not? All right, this will be a pretty obvious difference, right? So, paste, insert. This is the control group, and this is the experimental group. So we have 5 meter tall tomatoes here. We have 10 meter tall tomatoes here. Clearly, there's going to be a difference, but you have to do the stats. So what you have to figure out is insert to the left. Is you have to figure out the 3 things that I asked you to do before: the mean, standard deviation, and count. Count's easy, right? Just however many you copy and paste it over. And then you're going to take those 3 numbers, put it into the t-test calculator, and tell me what the significance is. Right. I'm just going to tell you right now that these are going to be significantly different. Like, you can just eyeball it and be like, yeah, those are different. So, do you guys know how to use Excel? Tomato. Yeah, you're getting graded on correct guesses, but you also have to actually run the stats. And so you're going to have to tell me, you're going to report to me on Canvas, what is the mean, what is the standard deviation, what count you're not graded on the count, but I want you to report to me the count you used. And we just pick one other person's code. Yeah, I'm gonna create I'm almost done this. I'm gonna create clone versions of Vargas's and Arias's or whatever, and just pick one of the students that I clone, and then you're gonna respond on Canvas like with these numbers. What is the mean of Arias 1 versus Kearney Arias 1? Vargas 1 versus Vargas Kearney 1. What was the means? What were the standard deviations? What was the count? And how significant? What is the significance that they're different? That's what you're going to respond with. Okay. So mean. If you want to, if you're outputting printing with comma, then just save it as a CSV file, and Excel can import CSV, no problem. So the mean here. How do we do a mean in Excel? Equals. Anytime you do equals, it is going to do a calculation. So if you just type the number here, the number appears. But if you type equals, then that's going to do a calculation. It's a formula. So I'm going to say equals average, and then I'm going to say from B2 to B33, which I can type out directly like this. Or the faster way of doing it, perhaps faster, is you just select it with your mouse like that, and you can see it types it in for you. Close parentheses, hit return, and there's your average height of the tomato plants. And then if you want to do the same for the column to the right, you can click and drag on that little box there, and it will do a right fill. Another way you can do that is you can select the boxes like this and hit Control R. R is for right, and it right fills it for you. And yeah, and you can see when you do that, it actually updates the equation. So when you fill right, it actually will update the B2 to B33. This is B2, right? B2. C2. So it actually updates the B's to C's when you do a right fill. Okay. So add all divided by n. No, you don't have to do that. You can do a standard deviation equals stdev. What is it? Standard. No. Stdev. There you go. Based on the entire population given its arguments. Like you. Thank you. Nope. From you to you. There you go. And right fill. There you go. So you can see it updated from B2 to B33 to C2 to C33. If you click on it, it'll show you the data that it's operating on. Make sure that you don't have an off by one error when you do that. It's quite common, like when you're working on the standard deviation, for you to include the mean or something like that, you know, which for the mean, it's not going to be a big deal, but like if your mean includes the standard deviation or something, it's going to be wrong, right? And then for n, you can just eyeball it, all right? That's 32, all right? It'll tell you, or you just say from 2 to 33, or you can, if you want, you can say count, and you can pass it the column of data as well, and that's 32 as well. Right fill, 30, what? No. 32, I don't know what the hell happened there. Okay, so that's that is your that's your assignment. Okay, and if these data change, you can actually see the equations will update down below. Kind of cool. So if you made a mistake, usually when I do this assignment, I insert negative values and things like that. I might do that here as well, where I will sometimes give you a bad measurement, and the bad measurement will be like -1000, and so you have to clean the data. The first thing you always do when you're looking at this stuff is does my data like look okay? You know, like if you're measuring tomatoes and you got 10 meters, you're like, that seems wrong to me. You know, if you're measuring tomato heights and you get -30, like you can't have a negative height. You know what I mean? Like it's not possible. And so you have to throw away bad values. And that's a whole art in and of itself. It has to be documented in the paper. How did you clean the data? Because people will sometimes clean the data to fit whatever conclusion they want to make. So there was a Greek mythology, there was a person called Procrustes who had a bed that always fit people. And he always fit people because if their legs were too long, he would chop off their legs. And if their legs were too short, he would stretch them on a rack. So he would make his data fit his conclusion rather than the conclusion fit the data. So it's called Procrustean economics, where you torture your data to get whatever conclusion you want. It's in here somewhere. Okay, so basically, then you take these three things here and feed it into that calculator. There is a t-test. There is a t-test in here somewhere. T-test. But I would just take these. I would just take these three things here, and just put them into the t-test calculator. Okay. You can do it 3 times, once for each of the 3 programs. And the final question is: are they different? Because that's what we want to know in science. Did it work? Did it work? And how confident are we that it worked? Yep. So at the end of the day, you're going to come up into the... you're going to come back into that t-test calculator. Mean, standard deviation, and n. Mean of this is 600. Mean of this one is 1040. Standard deviation of 34, 74, 32, 32. Hit it. And as you can see, it's highly significant. Okay, highly, highly significant. Extremely significant. As you can see, because it goes from 600 to 1,000. Right? So, yeah. Are they different? Yes. P-value, P is less than... That's what you're going to do. Okay. No actual programming. That's what I said. For this assignment, very light on the programming. Your programming part's done. You just had to make 3 random number generators. It's part of the fun. And now I'm going to make random number generators to match a couple of the students. I'm not going to do it for everybody, but for a couple of them. And I'll have that done probably by midnight tonight. And then you got a week to generate data. And you can make as much data as you want, by the way. So if you get something that's like indeterminate, you know, like it's like a p-value of like 10, run more trials. Get more data, you know? Because if there is a difference, doing more trials will kind of tease it out. You know? Put more data in there. All right. Extract and clean, and then get the stats and answer the question. All right. And so I'll pick I guess Vargas's, Arias's, and I don't know, maybe one other student or something. No, I'll let you know which one I pick. Okay. So that's it. That's the class. Hope you guys had fun this semester. You know, I almost want to apologize for torturing you with graph theory, but I really don't, because it's that important in computer science. It's literally the most important thing we did. So, you know, getting that graph traversal process down is super important. And it's torture. Other things, takeaways from this semester. Recursion, anytime you work on recursion, kind of drilling into your head, base case and inductive step both have to be good. That's like a huge takeaway. Learning how to simplify if statements, which we could have done more of. I feel like we could have I could have given you more worksheets on that to simplify things and use Carnot maps and things like that to take an if statement and knock it down to size. That's actually really useful too. Combinatorics comes up a lot. You know, how many ATM passwords are possible. Like just the other day when I was working on something with another professor, it was like we were like eyeballing like how many possibilities there were, and we were just casually tossing out, oh yeah, it's gonna be 7 choose 3 times, you know, like just tossing out. It's just part of the vocabulary, you know, the combinatoric stuff. And then probability and statistics are like the bread and butter of science, right? And even if you don't go into science, you know, even though computer science is technically a science, it's kind of engineering more sometimes. Just as a human citizen, whenever you read a science article, like Science Direct, you know, let's find out what happened in science today. Ivermectin. It's probably going to get me canceled on YouTube. 20 randomized clinical trials have tracked inpatient outcome. 6 of 7 meta-analyses of ivermectin reported finding notable reductions in COVID-19 fatalities, the mean 31% relative risk of mortality. Yeah, so whenever I read a science paper, there's 2 things I look for. The first is the effect size. How effective was it? And 2, was the effect significant? Because those aren't the same things. You can have a very weak effect that is significant. Like, you know, this drug, if you take it, will lower your blood pressure by 1%, and we're very certain it will lower it by 1%. It's harder to find that data, but you can establish it. During mass IVM treatments, excess deaths fell by a mean of 74% over 30 days. So that's a fairly significant, that's a large effect size, right? 74% reduction in excess deaths. All right. And look, here we go, with a p-value of less than 0.002. Highly significant and a large effect size. That's what I look for when I look for science reporting. Okay, those two things, the effect size and the p-value. If those aren't in there, I'm just like, I don't believe you. If I was on, what was it, Lance Armstrong's Live Strong or whatever, is that his website, something like that. So if you go on to Live Strong, like there's a whole bunch of just nonsense pseudoscience. Bracelets, and like they have these like bracelets that improve your blood pressure or something. I don't know. $1 bracelet. I don't know. And I don't know. Like the let's see if I can find some horrible science news. It shouldn't be hard. Let's go on to Google News, I guess. You gotta go. See ya. Thanks for being here, McCone. Science reporting. Business, technology, entertainment, sports, science. Okay. Okay, here we go. 1 in 44 children affected by autism. So that's the effect size, right? Or, well, it's not really an effect size, it's just an observation. But, it's giving you a number. And that's up from 1 in 54. CDC report says that they're 50% more likely to be diagnosed in 2018 than 2014. And there's probably not going to be a p-value anywhere in here because this is the AP. So the AP included a effect size, no p-value, right? Pretty standard for science reporting. Science reporters very rarely, and sometimes you'll just see them say like, this is a significant finding, this is a very significant finding, things like that, or it's a preliminary finding. Like they'll sometimes put an English spin on the p-value. Most of the time they don't, and so most science reporting is garbage in this country for that reason. Try goop. Yeah, exactly. It'll if you eat goop, it'll improve your heart. Well, how much? Where's the study? What's the p-value? You have an experimental group, you have a control group. Let me see your data. I'll run it myself. And by and large, they won't have that. So science journalism is almost universally terrible in this country. And that's just kind of the sad reality. And so I will dig behind the articles and try to find the underlying science. And a lot of times they're paywalled. They're behind a website that you have to pay money to. I'm like, okay, I'm just not going to believe you then, Or you can find an arXiv sometimes. But, basically I need to see the underlying science in order, at least give me those numbers. Like even if I don't redo the experiment in my head, I need to at least see those numbers to know if I should believe you or not. So that is that. Thank you guys for a great semester, and no class next week. You just got competency exams and your last homework assignment, and you're out of here. Have a great winter. Have a great life if you're not coming back, and thanks for everything. Peace out, you guys.